Section 8.6, we discuss choosing a factoring method or the best factoring method. We're going to split this into a couple days, but essentially it's just if you're handed any kind of factoring problem, do you know the proper steps to take in order to get it factored? So we want to be able to choose an appropriate method for factoring a polynomial. Remember, when you are factoring, the first thing you want to do is see if there is a greatest common factor. Is there something that you can factor out in front to make it a little more simple to actually factor? Then you need to look and see what you have left, and if you can break that down, or essentially factor what's left over after you take out a greatest common factor. If there is no greatest common factor, we just break it down into the two parentheses and the two binomials. Also, we have to pay attention to if there's no middle term, is it a difference of squares? And also, is it a perfect square trinomial? Because remember, those are pretty easy to factor as well. So let's go back and practice a few examples of factoring out the greatest common factor. Remember, when you're looking for the greatest common factor, you're looking at the coefficients to determine what number you can pull out of all those. And you're also looking at the variables. Do they all share a variable? In which case, how many can you factor out? So our coefficients, we have 4, 16, 12, and 8. And the largest number you can factor out of all of those is a 4. 4 evenly divides into all four numbers. Then we have our variables, x to the 5th, x to the 4th, x cubed, x squared. So what's the most number of x's you can factor out from each term? And that would be a 2. That's the most this last term has to give, so that's all we can factor out. And then we always rewrite what's left over. From 4x to the 5th, I've factored out a 4x squared. That leaves me with x cubed. I factored 2 of the x's out. I have 3 left over. Plus, I had 16x to the 4th. I'm left with 4x squared. 4 factored away from 16 leaves us with 4. I had an x to the 4th. I took out x squared. I have x squared left over. Plus 3x plus 2. Remember, if you were to distribute that 4x squared back through the parentheses, you should get the original problem. Go ahead and try this one. 4a cubed b squared minus 6a squared b squared plus 2a to the 4th b cubed. So I can factor out a 2, a squared, a cubed, a squared, a to the 4th. And then as far as b goes, I can factor out a b squared. So what does that leave you with? 2a minus 3 plus, looks like a squared b. And did you get that one right? If not, do you see where you went wrong? And hopefully you can fix your mistake. And now we just want to factor x squared plus 4x plus 4. So there's nothing I can take out. There's no greatest common factor. So I'm just going to try to break down what's left over, or just break down the problem. With no coefficient in front, I know I just have the x's in the front of my binomials. And I'm looking for factors of 4 that add to 4. Well, the only factors of 4 are 1 and 4, or 2 and 2. And so it's x plus 2 and x plus 2. The back number is positive, so my signs are the same and they match the middle. This is actually a perfect square trinomial, since it breaks down into identical factors. Here we have, I notice immediately, no middle term. So is this a difference of squares? And yes, it is. X to the 4th, remember, is x squared times x squared. 81 is 9 times 9. And in a difference of squares, our signs are opposite. Now what I want to point out with an example like this, if we're going to factor this completely, and we haven't seen one like this before, we can actually go one step further, because not only was the original problem a difference of squares, we are actually left with one of our factors that's also a difference of squares. And I believe we talked that there's no such thing as a sum of squares, so the x squared plus 9 has to stay put. But this x squared minus 9 can actually be broken down one more time into x plus 3 and x minus 3. And so that's a little bit hidden. We need to bring down the x squared plus 9 because it's still part of our answer. But this back one, this back binomial or back factor, was also a difference of squares. Five, again, we have a difference of squares. 25 and 64 are perfect squares. We have no middle term, and it is a difference. It's subtraction. So it's 5x plus 8 and 5x minus 8. Number 6, we have to be a little bit careful. It might look like a perfect square trinomial because 36 and x squared are both perfect squares. But this middle term doesn't follow the 2ab rule. Remember, if this is x times x, and this is 6 times 6, this needs to be 2 times x times 6. And it's not that, so this is not a perfect square trinomial. And oftentimes with perfect square trinomials, it's just easiest to try to factor them anyway. You'll probably get to the answer just as quickly as if you actually figured out that it was a perfect square trinomial. So the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And our signs are going to be both addition because the back number is positive. They are the same, so it matches the middle, so 2 plus signs. And we need the factors of 36 that add up to 13. That's going to be 4 and 9. That gives us 4x and 9x for 13x in the middle. On number 7, we don't have a number we can factor out, so no GCF. We don't have a perfect square trinomial, so we just need to try to break down what we have. This one's kind of nice because both numbers are prime, the 2 and the 3. Let's talk about our signs. Remember, the back number is negative, so we have one of each automatically. 2 is prime, so I know I'm going to have 2x and 1x. I may switch them places in a minute, or end up having to switch my signs. But I need to get a negative 1 in the middle. So now I need factors of 3 in the back. So that's going to be 1 and 3. This gives me 1x. This gives me a minus 6x for a total of negative 5x. But I need a negative 1. So I'm going to switch the 1 in the 3 places. That gives me 3x and a negative 2x for a positive 1x, but I need a negative 1x, so remember, then all you have to do is change your signs. So 2x minus 3 times x plus 1 is your factored answer. Try 8 on your own. Again, no GCF here, so we're just going to break down what we have. I'm going to try 3x and 2x. Again, a subtraction sign in the back means I have one of each sign. And I'm going to try 2 and 5. So that gives me 4x and a minus 15x. That's negative 11x. The right number, again, the wrong sign, so I switch my signs to give me a negative 4 and a positive 15 for positive 11. And sometimes they work out really nice like that. It's the first combination you try. And no, I did not see that in advance. I wasn't really trying to get the right answer right away, but it does happen like that a lot. On number 9, I see a perfect square in the front and in the back. So my initial thought is that I maybe do have a perfect square trinomial. There's nothing I can factor out of 16, 24, and 9. I know this is 3 times 3. This is 4x times 4x. And the middle term is in fact 2 times 3 times 4x. So this is a perfect square trinomial. So it's 4x plus 3, 4x plus 3. Again, remember that middle term is a combination of 2 times each of these numbers' square roots. So 3 and 4x. That is 24x. Now, if you didn't see that or didn't remember about perfect square trinomials, then you would have done the guess and check method. You may or may not have started with 4's in the front. You might have started with 8 and 2, but because it's a perfect square trinomial, we know it's the square roots that go into the parentheses. Here we have 20x to the fourth minus 45y squared, and hopefully you're seeing right away that we do need to factor something out. So I'm going to factor out the 5. That leaves me with 4x to the fourth minus 9y squared. This is now a difference of squares. The front and the back terms are both perfect squares. We have no middle term, and it is subtraction. But remember, the 5 comes with us, and now we just split up our parentheses into 2x squared minus 3y, 2x squared plus 3y. Signs are opposite in a difference of squares, and you just kind of have to pay attention to your exponents on the variables to know how to split them up. I think this is the last example. We have 3x squared plus 21x plus 18. Hopefully you're seeing that you can factor out a 3. It's going to make it much more easy to factor. X squared plus 7x plus 6 is what's left over, and this is what needs factored, bringing the 3 down because it's still part of the answer. So we have x's in the front. Since we don't have a coefficient here, it's just x times x. And now we need factors of 6 that add up to 7. Our signs are going to be plus plus, so that's going to be 1 and 6. So 3 times x plus 1 times x plus 6. So are you more familiar now with choosing an appropriate method for factoring? Hopefully you are. We are going to spend a second day on this, but we will work on worksheet 8.6a.